Excellent.
Okay, good morning. Good morning to this is December the 28th, 2025. This will be the last meeting of the cosmology discussion group for the year 2025. My name is Harry Ricker, and today Roger Anderton is going to talk to us about scientific method, I believe. So, Roger, I've approved your request.
Philosophy. Yeah. Okay. I'll see if I can get it.
Okay, great. You can start.
Okay. Thank you. Yeah, you got the old things on the way. Let's choose that. All right. Yeah. Uh, Thank you for letting me give this talk. And it's about Einstein's influence on the philosophy of science, stroke physics, and his influence on the scientific method. And let's go to the first slide. Okay. Where is it? Click on it and it goes. So many decisions, and using that term to refer to those who think Einstein's relativity is wrong, don't realise that Einstein had a big influence on the philosophy of science. And so they don't realise that if they attack Einstein's relativity, there is more to it than just the theory. And the philosophy has changed to how supposed to be physics, all under the influence of Einstein. So it fits into this biggest scheme of things. So the way you're supposed to think about science or physics is supposed to be in the way that Einstein was doing it when he came up with his relativity. So I don't know how many disciplines have really looked into that issue. But
I have.
sorry,
I have.
okay, so you have, yes. But it's a very big topic anyway, because um, next slide. So here we go. This is Stanford Encyclopedia of Philosophy. And by the way, I'm not using ChatGPT because some people don't like it. So I'm giving what my information is from me myself. So you can look up these places. We go into a lot of detail about Einstein's philosophy of science. And the problem, well, of course, the problem with Einstein is he keeps changing his mind about things.
Well,
So,
Roger, I do want to point out one thing. Philosophy of science didn't really exist when Einstein did his theory.
didn't it?
The
Um,
philosophy of science is a kind of a modern post-Einstein creation, I
well,
think.
physics used to be called natural philosophy. It's sort of like trying to split the two things. You're supposed to be philosophizing about nature, and so splitting it between the two things like philosophy of science and then science itself, you're trying to split the subject up into different specialist things. So did exist to some extent, even though it's sort of like a separate discipline. So with Einstein, he did read a lot of philosophy from a lot of people, and that did influence his thinking. And so you got the philosophies like Kant and so forth, and Mach and others like it. And so he read a lot of that, and that influenced his way of thinking about things. And so when you're attacking Einstein's relativity, you also got the problem of how did Einstein, his way of thinking about things. And not only has the mainstream sort of like adopted Einstein's relativity, they've sort of adopted Einstein's way of thinking about science and physics. In the case of Einstein, he philosophized in one direction, then he would sort of like change his mind and he'd philosophize another direction. So if you want to actually follow Einstein's philosophy of physics, you've got a choice of what version of physics you want, if it is philosophizing you want to follow. So that makes more confusion. In the point of view of the mainstream, Einstein changing his mind about things, that's a sign of him being a genius that he's prepared to accept he was doing things wrong and change his mind about things. But when it comes actually to reading Einstein, it's a mess of confusion about uh, whether you should do things one way or do things another way, because it's not really clear why he changes his mind about things. So in the philosophy of science, physics, everything's still messed up. So restating uh, what was just said there in the encyclopedia, Einstein is well known as the most prominent physicist of the 20th century. His contributions to 20th century philosophy of science, though of comparable importance, are less well known. Einstein's own philosophy of science is an original synthesis of stuff. So when the mainstream adopted believing Einstein's relativity, they sort of like took on all this sort of like philosophizing to fit it into his way of thinking about things. I mean, if it's theory of relativity and so forth, it helps to try to make sense of it to understand how Einstein was thinking about things. But in my mind, it's still a mess. And when it's pointed out here that it's less well known, it's probably less well known by the dissidents. So when they attack Einstein, they now attack the whole structure of science physics, because the whole structure of science physics is now been set up to follow what Einstein wants to do things as. And so the mainstream expects things to be done the sort of way that Einstein does things. So if you want to attack his relativity, they still expect you to do the sort of thinking that Einstein was doing. They don't expect us jettisoning all of that as well. So this person is supposed to be a genius, and they've done lots of programs on it. So this one, they've had this actor portray Einstein as a sudden genius. And so the way he does things is, well, that's a genius way of doing things, and Einstein just adopts all of that as being the way to do things. So now getting on to the scientific method, this is what is supposed to be the scientific method. Ideally, you start from the top, which is the observation question, and you then do your research, your topic area, then you do your hypothesis, then you test with experiments, and then you analyze data, report conclusions, and then you check back with observations again and decide whether to go around the loop again and do more research. And so you're starting off from empirical evidence, really. You're looking at observations and trying to build from that. So next. But however, if we go by articles like this one, this is a philosopher, I think, and it's the review of Einstein's unification by Dong Jen. And so Einstein was trying to unify things into unified theory, and he didn't really get to finish that theory. So what this person is saying is, in a few short sentences, Einstein completely repudiates the empirical spirit which has ostensibly guided scientific inquiry since Francis Bacon. So basically what Einstein is doing is changing the way you do physics. You've got physics, what became physics, had the methodology which is coming from Francis Bacon, and then suddenly Einstein wants to do things differently. Einstein, he doesn't care what the data says. If the experiment hadn't been run, he would still believe the theory. Moreover, should the data have disconfirmed his theory, who cares? Data are often wrong. So Einstein's method is sort of like you're interpreting the empirical evidence from his theory. So you've sort of reversed this. You've not started from empirical evidence, you've started from theory, and you're trying to look at empirical evidence to conform to what you believe. So Einstein changed the scientific method, and his followers go by what he did. So it's been very influential that physicists, they become theorists, think, oh, I can start theorizing and I can come up with all these different theories, and I can then look to see if there's evidence for these theories, rather than the other way around, where you want to have empirical evidence, and that suggests the theory. And so I wonder then if dissidents like Zeffrey, the one who was mentioned a while ago, who thinks Einstein is wrong because of violation of the traditional scientific method, doesn't realize that mainstream thinks scientific method is no different under Einstein. If you go to the first paper on special relativity, this is on the electrodynamics of moving bodies, he published in 1905. There is no mention of the Michelson-Morley experiment, so it's theory really not based on empirical evidence. When it comes to courses and teaching relativity, they often find it helpful to say that special relativity is built upon the Michelson-Morley experiment. It's because the students expect there to be an experiment which suggests the theory, but actually that's not the way Einstein did things. He goes by theory first, then looks to see if it fits in the experiment. So hence, when he's writing his paper on relativity, he's not even bothering to mention the Michelson-Morley experiment. So if going by Einstein, he went by thought experiments and not empirical evidence. And so this is the great Louis Eason, who was a critic of Einstein's relativity for a long time. And his view, he wrote articles like Relativity, Joke or Swindle. And Louis was one of these great experimental physicists. And when he was subjected to looking at Einstein's relativity, he thought, oh, it's a load of nonsense. But sort of like the mainstream's response to that is to just ignore it. Like so many other critics of Einstein, the mainstream just ignores them. So Eason wrote articles like this one, which condemned Einstein for going by thought experiment instead of empirical evidence. And Eason says the following: Einstein's use of a thought experiment together with his ignorance of experimental techniques gave a result which fooled himself and generations of scientists. So Eason didn't like the way Einstein was doing physics, basically. You're supposed to go by experiment, empirical evidence, and then form your theory. But Einstein just throws all that out the window. So Einstein's thought experiments. There's a hallmark of this is from Wikipedia. Hallmark of Einstein's career was the use of visualized thought experiments as a fundamental tool for understanding physical issues and for elucidating his concepts to others. Einstein's thought experiments took diverse forms. In his youth, he mentally chased beings of light. For special relativity, he employed moving trains and flashes of lightning to explain his theory. So Einstein's formulation of special relativity, basically, according to him, really comes from him in early childhood and so forth, and in the early youth, where he was considering what would happen if you were traveling with a beam of light. If you had a beam of light and you were traveling at the same speed of that beam of light, then that's not a physical experiment you can really do. So he's just using his imagination to think of what would happen, and so that's how he's forming his theory. He's not forming his theory from empirical evidence. He's forming his theory from imagining what would happen in certain situations. So against Einstein, and go against the whole structure of how mainstream is supposed to be. You might say that everything it does is wrong, but that's your opinion. And if you're not going by what in their opinion is right, then it's you that is wrong. So this is a picture of Einstein sitting on a beam of light. Einstein managed to get his way of thinking about things into the way the mainstream likes to think about things. You think about things by experiments which you can't actually physically do, and then from that you're supposed to work out what actual experiments do. But if you sort of like doing from actual experiments, sort of like, well, how do you actually get from an actual experiment to one of Einstein's thought experiments? You go in different directions, so the whole thing is a total mess. But it's the way that Einstein's done things. Anyway, I've looked into these issues quite a lot, and recently I went to this philosophy day session on relativity. So now, from my perspective, how you get philosophically from Newton's physics to Einstein's physics does not make sense. And so that's one of my big beefs against Einstein's relativity. How did Einstein get from Newton to what he's talking about? It just does not make sense. But then the way he's doing it is he's imagining these thought experiments and doing whatever he likes with that, which don't immediately connect to empirical evidence. And so the way that these PhDs in the philosophy of science are tackling things now, this is what I get from this day course I went on. Einstein is right, thus Newton got practically everything wrong. And so now they're setting about correcting Newton by working out what Newton should have said. So if you're going by Newton, you're sort of like coming up with these things of absolute time and so forth. And suddenly with Einstein, you've got relative time, relativistic effects and so forth. And sort of like, well, how do you get from Newton to Einstein? Does not make sense if you really look into it. And the way these philosophy people are now treating it is Einstein was right and Newton was wrong. So they're trying to change everything that Newton thought to try to fit in the way that Einstein thinks about things. So this is how deep the thing goes. So there are different philosophies of science stroke physics, but the mainstream chooses the ones that support an Einstein perspective. You've got Einstein as being portrayed as a genius, and that's supposed to be the way you're supposed to do things. And so anything which you can tie into supporting Einstein perspective, then that's what they're going to try to adopt. So now on to mathematics. There are different philosophies of mathematics, and I did try to deal with this a few weeks ago. Well, I think I confused people, various people. In the philosophy of mathematics, that mainstream now seems to go by is formalism. So this is the Stanford Encyclopedia of Philosophy, and it's talking about formalism in the philosophy of mathematics. And by ontology means the nature of things. And so you're only concerned with when you've got a philosophical point of view of dealing with mathematics and formalism, you're only concerned with manipulation of mathematical symbols, and you're not really concerned with what those symbols mean in physical terms. And it's often allowed Einstein. The mainstream often allows Einstein to make mistakes, but those mistakes are supposed to be corrected. And the formalism, the mathematics is special relativity, and it's deemed correct. So the mainstream is looking at the mathematics as formal from a formalism point of view. And in that case, the mathematics of special relativity is correct. But that's only just thinking about it in terms of manipulation of mathematical symbols. If you're trying to connect that into physics, you get the problem. Well, if a person A says person B's clock is slower and person B says A's clock is slower, then that does not seem to make physical sense. So from a formalist point of view, you're supposed to ignore that. You're just concentrating on the mathematics has that. The mathematics has the person A saying the B clock is slower and the person A is saying the other way. So it's a split between the mathematics and physical interpretation. And on the issue where the mathematics is supposed to be corrected, I don't know where that is. When you look at papers on relativity, they all seem to be saying different things. So don't know where the definitive correction is supposed to be. What you've got in the mathematics or papers and the physics papers, you just got seeming like a large selection of sort of like different things being talked about without there being well, what is the definitive version of special relativity that you're supposed to be going by? There's nothing there. It's just people with different opinions about what special relativity is. So to a large extent, formalism is the shut up and calculate attitude. And people like Richard Feynman, who's considered a great physicist, seem to popularize that idea. And that's where you don't bother whether what you're doing in the maths does not make sense. And that does not make sense in the physics terms. You're just doing the maths and then checking it against experiment. So next I'm bringing up, this is the GMO Muller research project, and it's looked at 95 years of criticism of special relativity. And so it points out a lot of the problems in relativity, all the issues that people bring up about blaming about Einstein's relativity. And in the section on mathematics, it's giving you this. It's the for the mathematics, Einstein's derivation of the Lorentz transformations are fundamentally erroneous, so they're an error. The Lorentz transformation do not satisfy the group conditions. Einstein and Max Larry derivations of the pretended effects of length refraction and time dilation are erroneous. So the criticism from the dissidents is the mathematics is full of mistakes. And that's in the papers of people like Einstein. But from the formalist attitude, you're not bothering about those mistakes. You're just considering all those issues as relevant. You've got this mathematics, Lorentz transformations, and you're just treating it as symbols which you manipulate in certain ways, and then you're treating that as mathematics is correct. And you're not bothering about all these sort of like mistakes that people are pointing out. And then on the issue of theory and knowledge, this is still from the GMO Muller project, where people start complaining. It's declarations of pure assumptions to be principles, and finally laws without any further argument or proof. So Einstein is starting from his assumptions, in which sometimes get called principles, and it doesn't really make any sense as to what he's doing from it. That's one of the criticisms. And the derivation of positive statements from negations does not make sense. It's all the method that Einstein is doing. Relatives pretend that statement, not in contrast to theory, proves the theory. So these relatives are just making fundamental mistakes in the theory of knowledge, but they're sort of like accepting all of that. So the methodology, this is the criticism of the methodology of the relatives, and it's sort of like the transfer, the principal relativity of electromechanics is said to be in no contrast with any empirical result, and I sort of like I argue about that sort of thing. And the next one is assertion of effect in special relativity, e.g. the twin paradox and explanation of this effect in general relativity. It all does not make sense when you're trying to go from special relativity to general relativity. When Einstein wrote his special relativity, he seemed to abandon it suddenly and gave up trying to do things that way and just came up with general relativity. And he doesn't show how properly you get from one to the other. So he leaves all that a mystery. It's sort of like, where's the derivation from Einstein to get from one to the other? You've got all these guesses as how you connect the things. So special relativity is strongly philosophically protected by all these methods of using formalism as the way you're supposed to do mathematics. And the attack routes are not there. By scientific method deemed should do so in the Einstein way. So the mathematics deem that any mistake should be corrected, but the formalism overall for the structure of special relativity maths is correct. It's believed that maths fix experiments. So basically you're up against the mainstream and they believe all these sort of things which they think come from Einstein. So what I'm basically doing is stating the mainstream's opinion. They're not open to other opinions. If you have a new theory, then you have to fit into the philosophical structure they've inherited from Einstein, and that's their opinion. And they expect anything new to fit in some way to what they already have from Einstein. So that they're open to suggestions for how to change things a bit, but the overall structure is still believed to be what Einstein's talking about. So that's when dissidents go against Einstein's relativity. They don't realise the full enormity of what they're going against as per the opinions of the mainstream. The mainstream just have their opinion that whatever you're saying is wrong. They've already inherited their way of thinking about things. Finished, thank you. Oh, stops.
Okay, well, thank you.
Thank you.
That wasn't very long.
Half an hour, isn't it?
Yeah, we've got quite a long, quite a lot of time here to fill up. So does anybody have any comments? I have lots of comments.
Yeah.
No comments? Find that hard to believe. Okay, let's go back a couple of slides. I got a couple of I got a couple of presentational issues. So can we go back a few slides?
What slide number do you want?
Well, okay, go down to towards the end. I'm not sure I want to start. I could start here with comments, but let's go down to um, um, yeah, okay. Go up. Okay, this slide here. Where does this come from?
GMO Muller project.
Okay, so this is from in the previous slide. What wasn't really clear to me.
They are.
Okay, so the following slides are from the Geo Mueller research project.
Yeah.
Is anybody on here familiar with this Geo Mueller research project?
I'm not.
That's what I thought. Okay. Yeah, okay. Yeah, this will come up on the internet. I'm not sure if it's relevant to go into a discussion about the GM Mueller project, but because that's kind of in and of itself could be a presentation in and of itself. But I'll give you the short story. The short story is that in Germany they have a law, is my understanding, that you can kind of challenge the scientific community's beliefs, and they tried to use this law to say that the German scientific community were teaching Einstein, and that Einstein didn't meet the qualifications under German law to be taught in the schools, and that's what this project was attempting to demonstrate, that and that it was teaching Einstein was in violation of the German law. And I'm just kind of paraphrasing it. I don't remember a lot of the details.
What I remember from it, they didn't get anywhere.
Well, they got rebuffed by the scientific community. The scientific community responded with their usual smoke and mirrors answers that didn't really answer anything.
Yeah, so they didn't get anywhere. They complained about.
So the scientific community in dealing with Einstein, the typical thing is, since nobody can really define what Einstein said or didn't say, it turns out that you can defend him as you come to the end there, where what Einstein said or his theory could be interpreted in so many different ways. So it can be defended by just saying that the criticism doesn't understand Einstein's theory, so the critic is wrong.
Right.
And of course, nobody. So then you write a rebuttal saying that the person who said that was an idiot and didn't know what he was talking about, and essentially that accomplishes nothing.
Right.
So what you have is essentially nothing more than I'm right because I say so, and then it's a question of whose opinion is more important, the critic's opinion or the person who's the director of some scientific establishment at some prestigious government financed institution.
Yeah.
Obviously, the government's not going to say, oh, our administrator of our government financed institution is wrong.
Correct. So they go by prestige. The people who sort of like get Nobel physics prizes and so forth, they become the top authority on things. And they poo-poo anybody who's saying,
So that means that science is nothing more than we're right because we say we're right.
yeah, that's right. That's what physics is now.
Well, I'm not really sure that was ever any different. I would go back to my comment, go back to the beginning.
Yeah,
I think the assumption is that Einstein changed the philosophy of physics, but I would say that you could say the same thing about Newton. So after Newton
yeah,
became, at first there was a battle between Newton and the Cartesians, the Newton, which was essentially a nationalistic type thing. The British all followed Newton, and the Europeans or the continent, it's what's called the continental
yeah.
science, they all followed Descartes. And so there was a battle between them for a period of time. But then when Newton's uh, gravitational theory eventually won out
Mm-hmm,
due to its ability to predict the motion of the planets,
mm-hmm.
then they all basically adopted the Newtonian scientific method.
Yeah,
And so during the 19th century, everything was according to Newton. So
yeah.
how is that any different than in the current existence we have now, that everything is according to Einstein?
Well, you used to have everything was according to Newton, and you're wondering how to fit in Maxwell's theory and so forth to it. And then Einstein sort of like came along and managed to get the mainstream to go in a different direction.
Yeah, well, Maxwell's theory, it's an attempt. Maxwell's theory is kind of an example of the way critics approach Einstein's theory of relativity. After he produced his treatise, there's a lot of controversy about Maxwell's treatise, and people couldn't understand what Maxwell was talking about. They'd read his treatise and they'd say, we can't make any heads or tails out of this theory.
Hmm.
It's not, it's like, what did Maxwell mean when he said this? It's the same type of controversy. But everybody claimed that Maxwell's theory was correct, even though people could go to Maxwell's treatise, which was supposed to be the definitive statement of his theory,
Hmm.
and point out all these contradictions, just the same as we have today with modern physics today. There's these paradigms or theories, quantum mechanics. You people point out all these problems with quantum mechanics, but that doesn't seem to bother the establishment in any way.
Hmm. Yeah, but what we're talking about is the revolution of what Einstein has done to physics. And so you had physics before him and sort of like the revolution that came about, which is supposed to be due to him. And so if you're talking about all the other revolutions, well, that's another issue. It's sort of like you would
Yeah,
have,
but they're all somewhat in a way similar in the sense that after everybody sort of decides, oh, Newton is correct, then
Mhm,
everything, all of your scientific, to be a good scientist, you have to basically use Newton's method.
mhm,
And of course, nobody really knows what Newton's method was, but what they do is they sort of interpret it and into what they consider to be the good science that they're doing.
mhm.
And obviously, in the 19th century, good science was based on this mathematical method, since Newton did his proofs based on mathematics. So, therefore, mathematics was the tool that was the correct tool to do science.
Yeah,
And in that particular time, the main tool was the inverse square law. Um,
yeah,
and so when they did electricity and magnetism had to obey the inverse square law because Newton had shown that gravitation obeyed the inverse square law. So all they did was they they basically adopted a lot of the mathematics that had been used for gravitation. They applied that to electromagnetism, and it worked. Yay!
Yeah.
Mhm.
Yeah, but you still had the problems of how to unify the two things, electromagnetism and Newtonian mechanics, and it's basically that Einstein did that.
Well, prior to Einstein coming along, the unification was through the inverse square law, because you
Yeah,
could derive. So if you go to textbooks on electricity and magnetism, the earlier books in the 19th century and the early 20th century, they derive the electricity and the magnetism equations via the inverse square law. And that changed um, around world just before and around World War II, when they revised the textbooks to kind of do away with that Newtonian idea of the inverse square law being the primary law that physics was based on. And I think that was largely based on Einstein and relativity. They were trying to, um, update electromagnetism so that it fit better with the theory of relativity.
yeah,
So I think the method is, if you have a theory that everybody believes is a successful theory, then you have to follow whatever the approach is that theory advocates as
Mhm.
being.
Yeah. 1919, Einstein became famous for the claim was that his theory had predicted the bending of light, which was observed by Eddington. And so he becomes famous, and that suddenly becomes the way you're supposed to be doing physics, but you did have dissent against it. And that's
Okay,
what,
we got about a minute left.
yeah.
Um,
But basically, what we have with Einstein is a change from what was happening earlier in late 19th and early 20th century. Because that's if you remove Einstein, you're back to arguing about the old issues.
well, I think they don't want to change the textbooks, and they just rather change them slightly,
Hmm.
progressively, a small change here, a small change there, like they're doing with the mass, the relativistic mass business. They're making an adjustment to it rather than completely
Yeah,
getting rid of the Einstein theory.
yeah, that's right. That's so, but really, in my view, that's changing the theory, but they don't want to think of it that way. They're saying it's the same theory, even though they're changing things about it.
Okay, we got.
Hello.
Okay.
Thank you. Back.
I knew it. He was getting his tea.
No, I'm in the bedroom having problems with the laptop falling over and things. And after I did
All
that,
right. I think we went over this. I don't. Robert hasn't made any comments yet. I'm wondering what Robert has to say. I'm sure Robert knows a lot about this topic.
Well, I know some because my degrees are in philosophy. And you look even for a consistency, and I find you don't always find it. And between theory and observation, it's like a chicken and egg question, which comes first, and it's not always clear which came first because one builds on the other. And with Einstein, I don't think he just did everything like with mathematics or a priori from his head. I think he actually was influenced by the Michelson-Morley experiment in spite of what he says at times.
yeah,
But he goes back and forth between positivism, which I think he got from Mach, uh, and realism. And then one of the things, you see, Mach never believed in atoms, and Einstein, of course, with his analysis of Brownian motion, thought that proved the existence of atoms. So, I mean, you look for one clear-cut, consistent philosophy here, and I just don't know as you get it with Einstein. But clearly, one problem is that it, his theories, they became so entrenched that you can't even, like with the mainstream, raise doubts. I know there is such a thing as a philosophy of science association. I'm not a member. I'm a member of a general philosophy association, but I did try a few times to get a paper. It was just on a realist interpretation of Feynman's path integrals, and I could never get it accepted to get it past referees who are refereeing the conferences. So you can say something a little bit different, but you can't say anything too different, I find. And as far as like any particular philosophy to associate with Einstein, I just find he says different things at different times in different places. So I don't even find consistency there.
Yeah.
Well, critics certainly don't find consistency. That's one of the big points. And that, you know, that it's inconsistent, and but that doesn't seem to affect the belief system. And I think what you pointed out pretty clearly is that you have the gatekeepers. Okay, the gatekeepers who don't really want to foster discussion. You know, it's easier to not have discussion than to have discussion and air dirty laundry. I don't think they want to have a discussion about, oh, well, this particular belief has issues associated with it. And I don't think they want that. I don't think, which to me, I think is the most um, uh, distressing aspect of it.
Well, I know in
It's
academia, and I know this is true in physics, that you're just not going to have a good academic job if you don't, at least say that you go along with relativity.
I think they need to eventually stand up and get organized and say, well, hey, we have all these questions. There's a large group of people who disagree, and just present it in an objective and professional way. I mean, I don't know if it could do any good.
Well, I think the GMO project was trying to do that, and they
Yeah.
got nowhere. They got nowhere.
I wouldn't say that they got nowhere. I would say that the German government essentially brushed off their arguments, and
Yeah.
they wanted them to go away. I don't think, I don't think the German government wanted to actually face the issue that they had a law, okay, on the books that certain things were supposed to be done a certain way in Germany according to this law, and have these people who are not essentially a political party of any significance come along and say, oh, you're not following your law that you're supposed to be following.
Mm-hmm.
That's not something that a government organization wants to have going on. So it's easier for them to brush it off and try to ignore it than and if they can. The issue, as I see, is if you're a political party, and like, for instance, the AfD in Germany is becoming very politically powerful.
Who's the AfD?
Then they have a problem, and then they deal with you by a different means of suppression, like they're banning the political party. Okay. So, but if you're just a small minority, like the Geo Mueller project, talking about something that's esoteric, like they're not following their rules for doing science in German scientific institutions, that's something they can remove by simply having the authority of the institution say, yeah, well, these people are wrong, and we're following the law that we're supposed to be following, and so everything's fine.
Roger.
Yeah.
Didn't you post something? You asked ChatGPT or something about like what percentage of university professors have disagreements with relativity, and it's like more than half of them or something?
No, there wasn't disagreements with relativity, what you got is the
Oh, really?
mainstream physicists. They all say, most of them, majority say they believe in Einstein's special relativity, but when you start asking them questions about special relativity, they don't seem to really believe in special relativity. They believe in other theory instead, such as Lorentz theory. So they've all got their different versions of what they believe special relativity is. So when it was, that's where its 50% comes on. Approximately 50% of them don't believe special relativity. They believe in other theory instead, but they're all saying that they believe special relativity.
Well, they call the other theory special relativity.
Yeah.
As far
So
as I can see.
You've got ambiguity over what special relativity is. So you can claim to believe special
Exactly.
relativity.
Yeah.
You can claim to believe special relativity, but it's not actually what special relativity states in the textbooks and so forth. You believe something else. I mean, I think one of the persons was Spoot, SMOOT. He won Nobel Physics Prize, and he said there is a preferred frame in special relativity. Most people who believe special relativity say there's no preferred frame. So he believes a different version of special relativity to what most people believe in. And that's where all the ambiguity.
Well, I have seen like on a few occasions at different times over the past quite a few years that a lot of university professors disagree with relativity, though.
Yeah,
but they can't say so.
I've gone on lots of these adult education courses, and you start arguing with the people who are educating you, because I go there with a lot of knowledge beforehand about relativity, and their argument generally is that they're being paid to teach relativity and not being paid to teach alternative theories. So hence why they're not teaching what the alternative theories to special relativity are. They're just teaching you special relativity.
That's a bureaucratic avoidance.
Exactly. So they're not giving students sufficient information to realize that what they're being taught is wrong. They're not being presented, here you go, special relativity says this about the Michelson-Morley experiment, but Lorentz theory says something else. They're not being presented with that. They're just being told what special relativity says about the Michelson-Morley experiment. And so, and they're giving a false impression that the experiment is, that's the experiment can only be interpreted by special relativity, and there's no other theories. So they're just for giving false impressions to the physics students.
I'm not really even sure I understand how special relativity explains the Michelson-Morley experiment.
It's a mess. It's a mess, basically. But they don't really go into that. When you're a student, they present you a load of maths, and they give you a load of exercises to do after class to say deal with that maths, and if you're a student, you say, well, why are we going by this theory? And then they tell you, well, it's the Michelson-Morley experiment proves special relativity. So
What it proved, the
yeah.
Lorentz transformations, that I think Lorentz came up with them to explain the Michelson-Morley experiment. And of course, that predates special relativity.
That's a different
But the
theory.
equations are the same.
Yeah.
So
they're saying that Michelson, when a student says, "Oh, what experiments have you got to prove special relativity?" They point out Michelson-Morley experiment, and they often don't go into sufficient detail to explain how.
Well, I think like Lorentz tried to, he developed the Lorentz transformation to describe the invariance of, the illusion of the invariance of C, but then Einstein thought it was he just assumed that it was just the invariance of C without the one-way approach, that C is invariant through and through. And they mistakenly thought that the null result of the Michelson-Morley experiment meant that C is invariant, but the only way that could prove that is if one of there's the sensor and the light source, the sensor and the light source. If one of them was in motion and C stayed invariant, that would prove that C is invariant. However, though, they're stationary relative to each other in the box of the interferometer. I mean, well, then also Einstein said the ether, if it exists, it's superfluous and undetectable. And so there's sort of two different things, like, the ether can't be detected, but then there's also, well, it proves the invariance of C. So I don't know which one you
Well,
went with.
they don't, if they're teaching to physics students, they don't generally go into all that sort of thing. That sort of thing gets dismissed as to what they need to tell them.
Yeah.
That's for further investigations by the students. The way they like to present things to physics students is to keep it as simple as possible. And so they say that there's empirical evidence that supports special relativity, and they cite the Michelson-Morley experiment and other things like that. And they may not then often go into sufficient detail to explain how. But it sort of like bluffs the students off because they're presented with a load of maths problems, and you do the exercises and you work out the numbers and you get ticked right or crossed wrong for when you've done your exercise. The philosophical side of it, they don't really deal with.
Yeah.
It's a mess. It's a mess.
So can you tell us what it is, going back to your presentation, if you could put your presentation back up? I'm
Oh,
sort of wondering, what is Einstein's scientific method?
well,
I mean,
it's
can we make a definitive statement
no, we
about
can't.
what?
You can't make any definitive statements of what Einstein is doing because he's changing his mind. And so people, when they look at him, they choose one particular version of what he's doing. And in the case of the special relativity, he seems to be going by thought experiments rather than actual experiments. But that's only kind of trying to work out from what he says outside of what he writes in his physics papers, because they've asked him, did you know about the Michelson-Morley experiment in
All right,
19...
let's put your picture up again where you show the scientific method. That method, I think that I think that's an idealization.
Yeah, the idealization, that's the easier way to deal with it. I mean, there's other loops within that.
Right. Okay. So I'm not really sure that it progresses, that this is, I think this is an idealization of what the scientific method is.
Yeah,
I don't think that what they're teaching is, this is the ideal real world, the ideal world of the professors in academia. This is, what they would tell students, this is how science is done.
yeah.
But I think, as Robert pointed out earlier, I mean, it doesn't seem to be that this is really what happens in the real world.
Well, you have a circle, and the question is where in the circle you start. And I don't know if it even matters that much whether you start with theory or start with observation, because they kind of build on each other. Most observations are kind of theory laden, and
Well, it's interpretation of observation.
yeah.
And interpretation of observation depends on your theory. So Einstein seems to be starting with theory, which is arguable, of course, but he seems to be starting with theory. And from the theory, you are supposed to interpret the observations from the theory's point of view.
Where is
From-
theory in this illustration? Is
Hypothesis.
that
Hypothesis.
right? Okay.
Well, if with Einstein's mind experiments, you can't actually finish this scientific method circle because down at the bottom it says test with experiment.
Yeah.
If it's a mind experiment, you cannot test it.
Well, it's
So it
supposed
cannot be valid.
Well,
Well,
they did test it with the Hayfel-Keating experiments and particle accelerators. I mean, they tested it, but I don't know if it's fabrication of the results.
yeah, that's it. So Einstein goes from his thought experiments, and you're supposed to work out consequences from that thought experiment as to what actual experiments show. So he's working from theory down to actual experiments. But if you're starting from, if you ignore his way of doing it, start from actual experiments, you could start like theorize different things happening at unobserved by experiments that you can't actually do. So it's
so
messing everything up.
So basically, you would assume that observation question is Michelson-Morley experiment.
Yeah.
So
Yes.
it starts with observation question at the top, Michelson-Morley experiment, but
Yeah.
we've already pointed out that he doesn't even mention that in his first paper.
Yeah.
Okay, so his first paper, his 1905 paper, doesn't start with a question observation.
Correct.
It starts with proposing two postulates and then creates a theory.
Yes.
Okay, so one could argue from that. Then he never really completes the circle by, he suggests some experiments, okay, that are confusing.
Yeah.
There's the experiment with the clock at the pole and the clock at the equator, and he suggests some experiments, but there's no confirmation in his paper of those experiments, and then he never. And it seems that his supposed experiments don't really even follow from his theory. Okay,
Yeah.
so that's a problem. So I don't even think that one can even say that his theory or the way he presents his theory even conforms to the scientific method as shown here in this graph.
It doesn't go by that method. If you're supposed to be starting by empirical evidence, Einstein doesn't seem to be going by that. He's doing something different, and that's
Yeah,
influence.
he's jumping right to hypothesis and
Yeah.
and then right over to report conclusions.
Yeah.
And that's it.
But the hypotheses don't completely come out of thin air. If you do that, that's what's known as a priori.
I
People used
understand
to
that.
accuse Descartes of that, but some of the other continental rationalists really did it, including Leibniz. But where his hypotheses come from, I don't think it's just something arbitrary.
It's Einstein's thought experiments. He's supposed to imagine these things, and that's
Well, they can't test it. They can't test it with the thought experiment.
They
They
can't
can't
test it.
analyze the data. All they can do is surmise conclusions, and that's it.
Yeah. Yeah.
Sorry for interrupting.
Yeah, but he's sort of like he gives thought experiments, and then you're supposed to work out what actually happens in real experiments that you can do, and that's supposed to be connected to his thought experiments.
Yeah,
Come on, man, think it through.
So
yeah, the thought experiments, they came out, like, as far as I can see, a lot from electromagnetic theory, like what happens when you travel along at the speed of light on a light ray and things.
Yeah. So Einstein don't really make it clear what he's working from. I mean, you can gather he's working from Maxwell's theory in his 1905 paper on special relativity because he mentions that, but you don't really get quotes as what that he's going by.
Mm-hmm.
Yeah, that's another one of those. So is he starting from the Michelson-Morley experiment, or is he starting from Maxwell's theory?
Well, he doesn't say about Michelson-Morley experiment in his 1905 paper, but he does mention Maxwell. So you'd assume.
Okay, so we're not even. So his 1905 paper doesn't even start from the Michelson-Morley experiment. So
yeah.
So we think so. We're not really even sure where his observation question.
He says basically right in his first sentence, and that is about with moving like charges and things and the laws about them. That with Maxwell's that there's something that's not inherent in the phenomena. I think it's right. I think you had the 1905 paper. It's right in the very first sentence.
I don't really know where he gets that from when he refers to that. Is it a moving conductor? Where's he getting that from? He's not citing an experiment.
Well, he doesn't give a reference on that.
So he doesn't give references for anything. So you're not knowing what his starting position is.
So it looks like
I guess we're asking, what were the antecedents to his two postulates? Because the two postulates could be said to be where he started, right?
Yeah, And he gets that from thought experiment, presumably.
Well, presumably that means we should put hypothesis at the top of the circle
Yeah.
rather than off to the side.
Yeah. Well, the second hypothesis, second postulate, I think that one comes from the Michelson-Morley experiment. The other one is probably from his first sentence of his paper that these differences with the equations, they're not inherent in the phenomena for moving electric charges.
Hmm.
So they're not just arbitrary.
Well,
Roger, for
you're
your
not,
next,
you're not
sorry.
saying where they're coming from. So when he's saying the light speed thing, postulate, second postulate, he's not saying that comes from the Michelson-Morley experiment.
Yeah, I know he doesn't give references. You're
No,
right there.
he doesn't say that's where it's from. That would be a help, because you then say, well, how did you work that out from the Michelson-Morley experiment? Because not everybody interprets the Michelson-Morley experiment as giving that.
There probably are at least 10 different ways of getting the result of the Michelson-Morley experiment, including emission theories, but there are a whole bunch of different ways.
Ritz theory. I think Ritz was dealing with the theory which Einstein was looking at until he suddenly changed his mind for special relativity. So you don't get the transition of how did Einstein move from a Ritz ballistic emission theory to special relativity. You don't get anything from him. You don't get a chain of what is he working from, what is his thinking process. It suddenly, and what are the experiments he's looking at. You don't get any of that. You just go from, it's just a mess.
If you wanted to clear this issue up, you could have two diagrams, one for the old scientific method, or a correct one, and Einstein's circle of scientific method. And you could show the falsehoods in his thought processes.
Well, I think that with the mainstream, I think they're agreeing with the way he does things. So if you're pointing out the scientific method has been changed,
you could say this is the new scientific method.
This is the way you're supposed to do things.
Yeah, and this is the way they're doing it now.
Yeah.
Well, if we were to assume that there's some intelligence behind all of this story, it would seem to be that the intelligence is to create maximal confusion in the scientific community.
Well, I think
then it all makes sense.
Well, I can't say what Einstein is thinking process, but for everything I read from him, I think he's a very confused person. He just muddles things up, and so what he's presenting his muddled way of thinking about things.
Well, that seems to support my thesis that the objective is to create confusion.
Yeah.
And one result of the success of that is what might be called obsessive or obsession with the person of Einstein.
Yeah. Well,
it's part of the story to create confusion.
That is what we have been presented with as the publicity, that Einstein is a genius, and there's been a great deal of publicity pointing that out. So whatever Einstein is doing is deemed to be the genius way of doing things.
James, shut up and calculate.
Yeah.
But I don't know that we really have I don't know that you've identified what his method is. I think you've suggested that it's based on thought experiments, and then you showed this chart. But that chart doesn't really seem to agree with Einstein's method that you talked about. So, I mean, we should have started with thought experiments at the top, rather than some observation or idea.
Yeah.
So it seems to me that his theory doesn't really agree with the idealized chart, the idealized theory.
When you go by Einstein, he has his scientific papers. And he doesn't. I don't think he talks about thought experiments in the papers like 1905. And it's sort of like when people have asked him outside of those papers to clarify things, and that's when he comes up with going by these thought experiments. So then
he does mention the electromagnetic issue, which is kind of a thought experiment in a way.
Yeah. He's not really.
He's asking, why is it that if the coil moves, we have one explanation, but if the magnet moves, we have a different explanation.
Yeah.
And that's kind of, he's in, and it, but that's not really clear what he's talking about. The people don't even agree on what he means when he's referring to that.
Yeah.
Is he referring to the unipolar induction experiment? Some people claim that he's talking about unipolar induction. Some people don't agree with that interpretation.
Yeah.
And then at the end, towards the end of the section, he does mention the unipolar induction issue. And so it's confusing what he's talking about.
Exactly. A lot of things
Yeah.
a lot of things he's saying is confusing. I mean, I've gone back to the German and translated it myself into English, and I don't reckon that he's really saying that the speed of light is constant in his 1905 special relativity paper, but that's the way it's being interpreted.
Okay, let's go back to the scientific method slide. Perhaps that's not the best slide to describe Einstein's method, nor even science in general. I mean, is this too idealized or too simplified?
Well, where did you get the chart from, Roger?
You can look up these things on the internet and they tell you the scientific method. And this is a simplified version. I mean, there's extra circles you can add to it where you can sort of like do an experiment, analyze the data, and then go back and test the experiment again. So you keep going around in these circles. So you don't.
So you don't have a specific source that you
So
can name.
you're not. This is just simplified. This circle here, going around in that circle, you can have other epicycles.
Yeah, I think he's just saying that if you do a Google search, you'll get this type of image.
Yeah. Have you come across the hypothetical deductive method?
I think so.
If you form hypotheses, you make deductions, you run experiments, and you don't necessarily have to start with the hypotheses because they can be an empirical generalization. They can come from anywhere.
Yeah.
But then you never actually prove your hypotheses. At best, you can refute them. At least Popper points that out.
Yeah.
I have a comment here on this. I would call this the engineering method and not the scientific method.
And what's the difference between an engineer and a physicist as regards this then?
Well, that would be a good point. But the reason I want to call it the engineering method is the engineering method is a more of a complete. You go around the circle, and then in engineering, you go around the circle multiple times because you have a prototype, you build your prototype, you test your prototype, you find that the prototype doesn't really work exactly the way that you expected it to, and so you change your theory and modify your prototype when you do your experiments. And then you do experiments, and then you find out that, yeah, you still have some problems to fix. And so you keep going around the circle until you get to a plane that doesn't crash or a device that doesn't completely fail. And then you basically build it. And, like if it's a bridge, you hope it doesn't fall down. You hope you did your equations correctly. But if it's an airplane and it doesn't crash, then you go into production with it.
Yeah, well, engineers are normally dealing with devices and things, aren't they? With this, a physicist is trying to work on a hypothesis straight theory. He's trying to work out how the universe works.
Right, but you don't really complete the circle. The point is you pretend that you complete the circle because you don't really know whether your theory is correct or not. You just only are guessing that it's a complete and correct theory.
Well, it does have an arrow between report conclusions and observation questions, so that might imply that it's a continuous circle, so that that you can have a hypothesis, you can test it, you can analyze the data, you can report your conclusions. Then you can, based on the observations you just did, you can research the topic or the area in question and then form another hypothesis in physics. So you can do that as well, Harry.
Yeah.
Yes, but that doesn't
submit.
really happen because the institution of science doesn't allow you to actually complete the circle.
Exactly.
That's the problem. The problem is the criticism coming from dissidents doesn't actually get included in the method. So you can't fix the problems. So people have pointed out problems with Einstein's theory. The scientific community doesn't respond to that criticism. Whereas if you're an engineer and you're building an airplane and your airplane crashes, then you have to fix it.
Well, if you leave out test with experiment, then you can pretty much do anything you want. Period. And then, like, it doesn't matter what you're thinking. If everybody agrees with what you're thinking, then it becomes law. Basically, it's just not the right way. And Roger's helping point this out with this presentation.
Well, the test with experiment part is kind of that's problematical when it comes to Einstein and relativity and modern physics and science. You have in the case of cosmology, you can't really test cosmology with an experiment. You basically try to match observations. You try to make your theory match your observations. But,
well, the electric universe says you can, because electric discharges are scalable all the way up to the cosmos. So you can actually do experiments in the laboratory with electric discharge on surfaces, and you can show exactly the same things that you observe out in space. So carry on.
well, that's not how they're doing it, but
Well,
It actually is. They're the way that they have their experiments.
I'm talking about mainstream science.
Right. Okay.
That's a different science. That's a different method to approach cosmology. That's not an accepted method. I was referring to what they do is they measure the microwave background radiation spectrum, and they say it's 2.7 degrees K, and then they adjust their theory to produce that result. And that doesn't necessarily mean their theory is correct. It just means that they've manipulated the mathematics in order to get a consistent result.
Yeah.
Right. It's an ad hoc.
They didn't even calculate this temperature 2.7 K. Show me anybody who calculated it. Nobody except myself. I'm sorry. Where is the science?
Well,
where did that number come from?
We're talking. He's talking about before they found the cosmic background radiation. A lot of people had made guesses at the temperature. Some came fairly close, but a lot of people.
I'm very sorry. In your theory, I mean your electrical universe, do you have the number for this temperature? Do you? Nobody.
I don't.
Nobody,
including
you guys. You don't calculate. You didn't calculate any number.
I don't believe the people in the electric universe think that the cosmic background radiation is out there. We think it's more likely local.
That it exists. Okay. It's
we think it's local.
As usually. Pollution. I know.
Okay, so you have different, we're off on a side argument here. I brought that up merely to show that what the method they're using is that they're adjusting the parameters in their math model to agree with the data.
Yeah.
It doesn't really prove anything that I
It
could
certainly
see.
doesn't prove anything, and everyone does it. It's not just Einstein. Everyone does it. But if you get, like Lakatosh calls, either a progressive or a regressive research program, if you have to keep making these ad hoc adjustments, that's a sign that there's a problem with your theory or with your whole research program. And it's regressive because you have to keep patching things up. If you make predictions and they come out in accordance with your predictions when you run the experiments, that shows you're making progress. But
Right,
it
and
still doesn't prove truth.
the CMB it's based on the Big Bang, and the electric universe doesn't think the Big Bang happened. So it's the CMB. If it's local, I'm not talking about from the Earth, emissions from the Earth. I'm talking about emissions from the galactic Birkeland currents that we sit within, or emissions from the Birkeland current that is the arm of the galaxy that we exist in.
Mm-hmm.
All right, we're coming up. We got like just about a minute.
Yeah. So I
My
think
comment about this is the reason I brought this up is I don't think Einstein's approach really agrees with this chart here of the scientific method. That's my claim.
Yes, you're absolutely right.
We all agree with you, Harry.
Okay, so then the question is, obviously they allowed some change to the scientific method to allow Einstein's theory to be considered scientific.
yeah, the way
So then
Einstein does science is supposed to be the way you're supposed to do it.
well, obviously you have to say that, or else you have to say Einstein is wrong and his
Yeah.
theory is wrong.
Yeah. So you're going up against Lot when you're trying to go against Einstein's relativity, because you're going against the way he's doing physics.
There's no physics in Einstein theory. It's mathematics only, guys. What you talking about?
Well, I think that's the real change. Okay, so I'm going to go back to your thing there. I would say that Einstein's method isn't
Yeah.
isn't the scientific method. I don't think he uses the scientific method that you showed as your chart.
It's not the traditional scientific method. It's sort of like his.
Well, yeah, I think the scientific method that you're referring to is more of an engineering, the way we do engineering type of this chart here. This is more like how I was taught we were supposed to do engineering, which was supposed to be based on the scientific method.
Yeah. So engineers probably do the
Well,
scientific
you
method.
see, and engineers don't have to deal with Einstein and the questions that he's brought up. They
Yeah.
have to do. They only have to deal with electrons and how they move, and like all those equations work and are known, so they can use the old scientific method if they choose to. But I mean, they pretty much have to use the old scientific method because it's the correct way.
Well, the
The new
problem
way.
is that if you're an engineer and you build an airplane and the plane doesn't fly, that's the problem.
Yeah, exactly.
Okay. Einstein, his theory is so esoteric that there's no obvious way you can, it's a theory, time and space are warped. How do you prove that? How do you show that it's wrong? It's
can't.
that's the whole problem. It's ambiguous, it's unclear, there's no.
Henry, can I ask you the question? To his theory, mathematics, engineers, they're physicists. Physics, it's experimental science. Don't even compare mathematics and physics. Simple like this. In special relativity, general relativity, many times I ask you the question, guys, what does it mean speed of light? I don't know. What does it mean time even? There is no four-dimensional space-time. There is, it's not space-time because time, complex number, it's not time. I don't know even now. What does it mean time in Einstein theory? Nobody, tell me, anybody, what does it mean time in his theory?
Well, we could say it's not really actually a scientific theory, it's just a philosophy.
It's not scientific theory at all. It's scientific, maybe mathematics. You are checking your logic. You have your thoughtful experiment, but no correlation to real physics because physics, experimental science. And your airplane flies because of physics, not because of thoughtful experiment. No, it's simple like this.
Yep,
That's why
exactly.
it's not physics. Don't put. It's a mess. It's a mess. No physics in his theory at all. Because on the beginning, thoughtful experiment, but physics, it's not experimental thoughtful. It's a real experiment. I measured something and I want to explain him. So it's simple like this. Guys, we're talking about something, no correlation, no connection to physics at all. At all.
Yes, well, that's that's the conundrum. You have people who claim that they're scientists and physicists who claim, that Einstein's theory is correct, and therefore it's physics because they say so.
Theory of what? Even from mathematical point of view, Harry, you showed that mathematics wrong. Even mathematics wrong. No, theory
Right,
of what?
and that's another problem, which is,
It's
but of
not a
course, since
problem. It's killing everything.
you're not dealing with the real world, you're dealing with the world of opinions. Okay, that's really
Yes.
what it boils down to, is science is not really what it claims to be. It's not dealing with the world of truth and reality. It's in the world of opinions. So since what we're really talking about in the end is opinions, it's whose opinion matters the most, not who's got the most right, who's got the right opinion.
Its opinion means religion. It's
Right.
not
And so
physics. It's not science. Religion.
well, there's a lot of parallels with religion. You talk about the Reformation and the Catholic Church. The Catholic Church ran everything during the Middle Ages, and so they had the establishment. If you were, Martin Luther, he didn't agree with the Catholic establishment. It's a similar type of thing. You know, uh,
If you want one sort of counterexample, and there's some counterpoints to make on this, but from engineering, if you're designing a particle accelerator or like a cyclotron and things, I think you'll find that people at least think they're using special relativity with the mass increase with their design. No, there are some counterpoints you can make on that one, but that might be an example.
right. Well, that's where the problems come in, which is, um, what is the theory actually? What are the symbols in the theory mean?
Yeah.
Okay, so what happens is that the symbols, the things that the Lorentz transform is supposedly representing, they're not really well defined in Einstein's relativity. And so that means you can interpret the symbols as being verified in experiments. That's the real problem.
Yeah, one question is what type of mass you're talking about, inertial mass versus gravitational mass and things.
Right. That's that's a the mass is increasing. What is that's an interpretation of what the symbols in the equations are saying. Okay. And then you do an experiment and it looks like your experiment confirms that, but does that really prove the theory? Um, yeah, you could say it does. On the other hand, if you have an alternative theory that gives an different interpretation to the symbols, it
Exactly.
could
Yeah.
mean the alternative theory is confirmed as well. So now
Well,
you have
yeah. So you're confirming two theories, which so you need a crucial experiment to where they make different predictions. But even that doesn't prove anything because there might be another theory out there.
right. So the issue is presumably the scientific method, by going around the circle numerous times, is supposed to eliminate the other possible theories that you could have, but it's not clear that it does or it can.
Mhm.
So anyway, I sort of the real issue to me is I'm not really sure that there is any such thing as the scientific method. I think that you could even say that there's no uniquely true scientific method. There's scientific methods, and one can talk about different scientific methods and give different examples for them, but I'm not sure there's one uniquely true scientific method that all scientists follow.
You know, you're probably right there, Harry, but I think almost in the definition of doing science, there are at least some constraints by observations. Otherwise, you're not doing science.
You mean there has to be a failure criterion?
Something like that.
Right. Well, so to me, the weakness of Einstein's theory is there's no failure criteria.
Mhm.
Magical failure, you proved it, man. Let me remind you your own talk about his mathematics. Wrong.
Right. Well,
Failure.
that's the issue. The issue is, Dingle got into this argument with, in the 1960s, where he showed that the mathematics was defective, and they, of course, did they sort of abused what he was saying and misinterpreted his point of view, and then showed that he was wrong. And anyway, it's kind of a complicated story. But what they eventually wound up by doing was saying that Dingle's mathematical arguments was wrong because it was refuted by experiments, which was kind of a bizarre thing, because how do you prove that math is wrong by an experiment?
Mhm.
All right, you're right. That's why what we're talking about. What kind of method? What kind of science? It's not mathematics. It's not physics. I don't know what we're talking about.
Well, they
It's
hold math dearly, right? They hold it on a pedestal.
I
They
don't
put it
know.
up
And
there.
all the confusion, there is no even one definition. What does it mean space? What does it mean time? What does it mean gravitation and all this stuff? Never I understood what he talked about. And thoughtful experiment, it's something I can imagine, but I don't know how to prove even. Because you have one logic and he has another logic. And
Well,
what is
math
it's wrong even from mathematical point of view, then what we talking about, guys? Science, it should be consistency inside of it. Consistency. There is no consistency.
math equations are used to support theories, and they can also support theories that are incorrect. The math can be good, but the theory is wrong. And that's been proven many, many times. And these theorists use their math to say, look, here's the proof. It cannot be classified as proof if it's just mathematics alone. That's my
Well,
point.
there's a
Should
difference
be internal
between what a math
consistency of
proof is.
mathematics. Consistency mathematics. I'm not talking about experiment because there is nothing to talk about. There are thoughtful experiments. Thoughtful, no real experiments. What we talking about? The beginning of this thoughtful experiment. Then you can check only logic of mathematics. That's it. Simple like this. This is
Well,
the theory.
my point being is you can have a totally incorrect theory, but the math says it's right. That's
Right
my
now.
point.
Yes, you're absolutely right. It's exactly what we're talking about right now. It's an incorrect theory. From mathematical point of view, incorrect. And from physical, there is no correlation, even connection to real physics, because there is no experiments. And he claimed, if I understood you correct, Roger, that experiment always wrong. It's failed. It's not, you don't count experimental results. It's unbelievable. This is a physical approach to the physics.
I think the issue here is there's no fail criterion that's defined. In other words, what's the fail criterion? In Einstein's theory, there's no fail criterion. You say,
Yes,
well, it's
Chris, you showed
illogical. If you point out that mathematics is wrong, they say you're wrong. So that's not a fail criteria. That wrong, there's wrong. The mathematics being wrong is not a fail criteria. Then you can say, well, the experiments don't actually confirm it. That's not a valid fail criteria. The point
Let's
is
name it.
that
Yes, Harry. Let's name it religion, and that's it. I agree with you absolutely. Religion.
I think
I'm
that's
against science,
denigrating
guys.
religion,
I'm
frankly.
scientist. I cannot believe it. Religion, yes, you believe it, you don't believe. And so many confessions. Maybe one of the confessions, simple like this.
There you
Well,
go,
I think
Roger.
religion.
There you go, Roger. Your next graph, leave this one called the scientific method, and then
It's not.
call the other one, the Einsteinian one, the fake method, the false method.
Well, we should go by the do one for the religious method.
Yeah, sorry, the religious method.
Yeah, but
The
I don't like that.
scientific
That's
religious method.
denigrating religion, I think.
Yeah.
It's not scientific, guys. Consistency. There is no consistency. It's religion.
Religion needs to be degraded, as far as I'm concerned.
Yeah. When Galileo started off, he had a problem of it wasn't agreeing with the religious interpretation of the Bible. So he was pointing out these observations, and the critics were, no, it doesn't agree with what Bible's saying.
In my view, organized religion is
Yeah.
evil.
Yeah, so kind of
Okay,
like
so we
mess.
can't even agree about. So I think the issue is there's no fail criterion that is really being applied to Einstein's theory.
Yeah. I think with it was a con job for the mainstream physics community to accept Einstein's relativity, because you haven't really got a clear references from Einstein as to where he's getting his theory from. You kind of like it's suddenly just appearing out of nowhere in 1905, and it's sort of like all these things get added to it, and you're not a clear method of development or precisely what theory is predicting what, and which is explained by special relativity as opposed to other theories. It's never a proper theory, but they
Well,
accepted
it can't be
something.
falsified. That's
Yeah.
the whole point.
Yeah, they've never accepted.
And
They've
it doesn't
accepted.
meet Popper's criterion.
Yeah,
You can't prove it wrong. You can't falsify it.
It's
There's
not.
no fail criteria.
It's not a scientific theory, but they accepted it as a scientific theory, which is bogus. It was a con job. I mean, Einstein never explained his theory properly.
Oh,
And how did he get away with it?
Well,
He was just a front man.
Front man, yeah. So they had this massive publicity campaign that Einstein was a genius, and everybody was expected to believe in that publicity. And if you didn't, you were cast out of the mainstream.
Yeah.
well, I think the real issue here is that there's really no, you have a scientific theory that essentially can't be disproved. And so how can it be a scientific theory if it can't be disproved? Isn't that in violation of somehow the scientific method somewhere along the line?
It should be.
I mean, the scientific method that you're showing in this diagram implies that at each of these steps, there has to be some procedure or some recognized criteria for discarding,
Yeah.
right?
Yeah.
What is the procedure? What is the criteria for test with experiment? What's the criteria for the test fails?
Well, you can read these scientific papers about doing the experiments. It's not really that clear.
Yeah.
just
Well,
not
whether
that
you
clear.
hypothesize something and your your experiment fails, you got to go back to the drawing board
Yeah.
and create a new hypothesis.
The,
Period.
Yes, but if your theory is ambiguous enough to allow you to pass the experimental test, then you can proceed forward. I think that's the issue with Einstein's theory. It's not clear what it's predicting.
Right.
Yeah, but there is no experimental test with thought processes.
Well, if you want a point about Popper, who did come up with that falsification criterion for the scientific method, he did like Einstein, and he praises him for making bold hypotheses and then tests confirming it. And he may have been thinking of the eclipse experiment as much as anything
Yeah.
there. So it's not that Popper was against Einstein, but and the whole history, it gets connected up with politics. I think, unfortunately, in some respects, for a long time, the people who opposed Einstein, and some even got Nobel Prizes, like Stark, for example. It turns out they were also Nazis, and so you get all sorts of negative
Well,
associations from
Nazi,
that and things. So it's
they weren't,
really a mess.
They weren't Nazis originally. It was 1919 that Einstein became famous, and there was a lot of criticism of that. And then the critics who were opposed to him, a lot of them then became Nazis after that.
Yeah, a lot of the German ones.
Yeah. So it didn't really start off as a Nazi attack on Einstein.
No, yeah, that's a good point as far as dates go, yes.
Yeah, so it became a Nazi attack on Einstein later.
So the real issue is in the scientific method, perhaps maybe the issue isn't that, you go around the circle so much. It's what is the fail criteria that at each of the steps.
Yeah, well, it's
If
not
the
that.
fail criteria, huh?
Well, the scientific papers, when you're trying to work out when they're doing the experiment, they normally just say, "Oh, this experiment agrees with Einstein," or it disagrees, and they don't. When they say it agrees, they don't really go into sufficient explanation of how. It's sort of like that's just a little bit. They do the way up the experiment, and they don't do the theory bit of how it connects to the theory, because everybody's got a different version of what they believe the theory is for Einstein. So they don't actually go into the theory bit.
Yeah, that's a way to avoid refutation is
Yeah.
you just shift to a different version of a theory. And I think that
Yeah.
does occur. And I know one specific place, like with entanglement, they
Yeah.
save relativity by saying you can't use these correlations for sending a signal, and they come
Yeah.
up with some sense of a signal where that
Yeah.
comes out true, and they have various proofs. But to me, that's actually very good evidence for a special reference frame, and that goes against relativity, which says all reference frames are equivalent.
Yeah, but it's sort of like when they talk about special relativity, they say this is what that theory gives, and then they say, "Oh, it's a quantum effect," which you have to add later further on. So it's usually a quantum effect for entanglement, which makes the thing even more confusing.
Mm-hmm.
So again, my question is, what is the failure criteria? There doesn't seem they don't seem to actually have failure criteria
They don't seem
in
to have.
science.
What they do is they just seem to add more to the theory. I mean, sort of like you've got dark matter and dark energy, and that doesn't count as failure of general relativity. It just becomes an add-on.
Mm-hmm.
That's what they do. So they say, "Oh, we're still going by Einstein's relativity," and then they do all these sort of add-ons and modifications.
Yeah,
Well,
Popper calls that immunizing a theory from
Yeah.
refutation, but he doesn't seem to see that that's what's happening with relativity.
Well, it was at the early days, I think, with relativity, because Einstein was saying all his stuff, and he wasn't. Then later on, these people started modifying relativity.
Well, I submit that the curve of the galaxy rotation has nothing to do with relativity. Dark matter and dark energy were invented to answer that question.
Yeah. You got other theories like modified Newtonian dynamics, but most of the time they're just trying to fit it into Einstein's relativity.
Right, and just like the bending of light around bodies in space.
Yeah.
they attribute that to gravity when they could very well attribute that to an electromagnetic effect of plasma being surrounded by each body in space. That body attracts plasma around to
Yeah.
it, and that is what's bending the light, not the
No,
gravity.
I think that'd be refraction, I think. And
Yeah.
Eddington did consider that possibility. He came
And
up.
plasma is known to be able to manipulate light.
Yeah, but that Eddington, I think he wrote stuff saying he considered with the refraction idea, and he found reasons for not going with it. So you're built on.
Okay, if there is a plasma around the bodies,
Yeah.
what about GPS? It's confirmed an Einstein theory, or it confirms existence of plasma? Tell me.
Sorry?
You have your plasma around Earth. There's some corrections we done with GPS. It confirms Einstein theory of special relativity, or it confirms existence of plasma.
Well, plasma is naturally attracted to larger bodies out in space. It's electromagnetic in
Everybody
nature.
knows. I ask you the question. The second one without any answer. I ask you a real question. It confirms existence of plasma, or it concerns validity of theory of Einstein.
You're
Well,
asking the
Dr.
wrong person.
Zaffe would argue that it proves that his magnetospheric theory, that GPS proves his magnetospheric theory. That would be Zaffe's
So many
answer.
times I heard about all this effect, this delay, something like this. It proves, confirms the Einstein theory. I'm totally confused. It's exactly what I asked you. I agree with you. Plasma, magnetoplasma, it doesn't matter. The real, the real medium around Earth. Yes, I agree with you. But I'm asking you the question: you discontinue to believe in plasma and started to believe in Einstein theory, or you believe in plasma only? Then Einstein theory doesn't work at all.
Well, again, there's no failure criteria for Einstein's theory. The criteria is any argued failure of his theory is wrong by some kind of immunization argument.
Yeah. Is it
Okay.
Einstein's
Sorry.
immunized? You can't prove him wrong. You've got his whole method of science and physics, and then you can do small
You
modifications.
cannot prove the existence of plasma. I don't understand you guys. For his theory, it's religion. I told you already. You cannot prove yes or no because it's a religion. You believe or not, that's it's simple like this. I'm asking about the plasma around Earth. It's according to GPS experiments or not? Okay, sorry.
Well, you probably need to talk to Ron Hatch.
GPS needs to be corrected, or it lacks the accuracy of relativity. It uses Lorentz transformations, doesn't it?
It doesn't
Yes, but
matter
it
which
doesn't.
transformation you're talking about.
It
It's in
uses a
principle.
Lorentz transformation for circular orbits and Lorentz transform.
Okay.
I'm sorry, I missed you
The
one more
velocity
time.
used in the Lorentz transformation for GPS is the velocity of the orbit going around the Earth, not a linear velocity. It's a circular velocity that they use.
Right.
So right there, you have a fail.
Mm.
So there's no fail criteria. That's the whole point. There's no criteria that says it's wrong. But the fail criteria would appear to be just opinion.
Well, it's always about perception, what we perceive, and how we think things are
Well,
is part
yes,
of
and
that
because
perception.
if I'm the president of a university or the chairman of a physics department or the director of the NASA or a scientific governmental agency, I'm going to say that Einstein is correct
Yeah.
Well, your
because
paycheck is
they
based on that.
Yeah.
correct. So there's no fail criteria. There's nothing that says it's wrong or it fails.
Yep. That's probably it.
No accountability.
Well, what happened was in 1919, it was taken by the establishment that the theory was proven by the Eddington observation. And it's very difficult to go against that. They've sort of like taken that as their foundation.
But that's
Yeah,
not
because there
even
was no
special
ether.
relativity. That's general relativity.
Yeah, but you go by general relativity, and it's supposed to be tied into special relativity. So,
Well,
so
no,
all of
but
it.
so then basically there's no fail criteria because they've basically ordained that the theory is correct.
Well, that based on observation, empirical
Well,
evidence.
based on their assumed
Yeah.
test, which could or could not be correct. There are lots of people who have contested the
Yeah.
Eddington results, and of course they're ignored.
Yes.
And so when somebody publishes a paper that says that Eddington's results were wrong, then somebody else publishes a paper that says, no, we've repeated the experiment and Eddington is correct.
Yeah.
But
So,
that doesn't really prove anything because you really don't have a definitive fail criteria.
yeah. Another thing is they don't do is they don't want to consider other theories as explaining that Eddington observation. They just want to go by one theory. They don't want to consider alternatives.
So in other words, there's no uniqueness criteria for proof of a theory in science.
Well, where they just want to go by one theory and ignore alternatives. They say that they've done an experimental observation that fits Einstein's relativity. Let's ignore other theories unless other theories predict something different which can be observed.
I think it
Well,
comes down to this.
That's a
I think
philosophical fail, in my
Yeah,
opinion.
yeah, but they don't.
I think it comes down to this. Do you have an open mind, or is your mind closed, unable to see other possibilities? That's
But science
where
is
we're
not
at.
about seeing other possibilities. It's about what is professed to be true.
Right. Well, if there's an area where it's not testable with experiment, then you have to be able to have an open mind to see other possibilities. If you don't have an open mind and you think that this is the way because everybody around me tells me that this is the way, then okay, this is the way. You have a closed mind. You're not able to analyze other data or other hypotheses. You have a closed mind, and that's a lot of the mainstream. They close their minds because of money.
Well, it has to do with the credibility of the government and education. So in other
Well,
words, if you admit that there's a possibility that what you're teaching is wrong, that's kind of a dangerous thing.
yes.
Well, and if you know it's wrong, then that's
That's even
legal.
worse.
And a lot of these scientists know that their line of questioning is wrong, but they still submit for applications for money. They want funding to carry on with experiments that they know that they're completely wrong. They're in it for
Well,
the money again.
that's not their fault. That's the government's fault for giving them money.
Well, the government doesn't know any better. They're not scientists.
You mean politicians? Well, the government, the scientists who are in charge of NASA and the National Science Foundation, and I'm referring here to, of course, to the United States agencies, they're supposed to know what good science is and only give money for
Supposed.
good science.
Right. And contained within that good science, so-called good science, is Einstein's bad science. And if you have experiments that you want to do based on his bad science, you'll get money for it.
Well, I
Other
think the
people,
bottom line here
no.
is that what is good science is politically defined. So in essence, basically, it all kind of comes down to politics and the formulation of how political opinions are formed. So, it essentially boils down to opinions and formation of opinions. Einstein is a good scientist because they've established that through the political process that Einstein is a good scientist who has a correct theory. And to admit otherwise would be embarrassing to them.
Unfortunately, you're absolutely right.
Well,
Another
Well,
approach.
everybody has seen Sabine's video of fraud in the scientific community, and that's her perspective from the European area where she deals with mostly. It happens in the United States too, and there's money being given to these projects that they know that it's not going to go anywhere. They're just going through the motions just to get the money.
Well, Rick,
Well,
that seems to be time to call in the lawyers. There should be a class action suit against the principal investigators of these multi-million-dollar projects, as well as the bureaucrats that run Fermilab and CERN and other major laboratories for fraud.
Yep.
Well, the lawyers are
the American taxpayer. Okay.
The lawyers are making more money by suing corporations than it's not profitable for the lawyers, I think, because there's not yes, but you're right. You're correct about that. But that was basically what the Geo Mueller project was aiming at, which we talked about earlier.
Yeah.
That was really basically what they were trying to do. What they were trying to point out.
Was that project, Harry, actually played out in the courts in Germany?
No, it never got to that because I don't think they had the money to take it to court. But
the governments didn't have the will.
They raised the issue, and the bureaucrats basically found reason to ignore the issue.
Okay, well, in the U.S. with the National Science Foundation, for example, you have principal investigators, which are basically taking taxpayer money and dispersing that to physicists and engineers around the world, where you get your 100-author papers out of. And in fact, perhaps the citizens of the U.S. should launch a class action suit to demand that these funds from the taxpayer, for example, one outcome might be that the scientists getting these funds must be freed from the fraudulent premises of the projects that they in their grant proposals.
Yes, okay, we're coming up to the end. A good example of that would be the climate change green energy fraud. That would be, but there's so many things that you can challenge as fraudulent science that that's a bottomless pit. Yeah. Okay, we're coming up to the end here. I mean, it would be great, James, if one could do that. But I mean, there's so many scientific frauds going on. not only that, but you have the political frauds that are going on, which we have this business with the fraud in Minnesota, where they're just literally stealing money.
Yeah, you've got a good point, Harry.
Hand over
I just
fist.
wanted to bring up that there may be a legal aspect to this, that, you know, we're saying that people are pursuing theories and writing grant proposals based upon theories which really do not have merit, and therefore they are actually defrauding the American public, the taxpayers. The same would
They
apply.
have review committees that